I think you
Good to
answered
know.
my
Okay,
3.3 question last time.
then let's go.
Wait, no, that was 3.2. Yeah, no, 3.3 was, oh, I think there was actually a question that Sadie asked that I also had a question on, but since she already asked that, I was able to do it.
Okay, sounds good. 3.4 then. Yeah, we'll just move our way through.
This is all you, Enrique. I don't.
Yeah, so I didn't know for 161, I didn't know how to get, wasn't sure how to get the revenue function.
Gotcha.
Um,
Okay.
or wait, is that 3.5? No, this is 3.4. 161, sorry.
161. Uh huh.
Um,
Let's see if it's a quick thing, and if it is, let's do it. And if it's going to be a long-winded sort of discussion, then we're
Ah,
going to
this one was weird.
for chapter 4 stuff.
like I know how to, the marginal revenue is the derivative of the revenue function. But when I looked at my notes, the revenue function wasn't like the derivative of the price. I mean, it was related to the total cost and something. I was just kind of confused. So
Oh, interesting. What page number?
I don't actually have the PDF.
I
I
got it.
haven't I haven't downloaded it.
Oh, I haven't
Good.
downloaded it either. I just click it on the web. It is scrolling. This is 3.4 scrolling. That's 3.6. Still scrolling. You know, it's at this point I wish I bought the Logitech mice where I can just infinite scroll. On 3.4, it's 266, and the questions are on 273 and 274, which is what 161 is on.
Uh-huh. Oh, this is one. Hold on. It's 161. All right. Sorry, guys. We'll get there. 1 second here. This is going to be this right here. And are we good here? 3.4?
Wait, why does yours say
Yes.
281? Oh.
Because it's a PDF version of it. That's why.
Oh, right. I was just looking at the page number. My apologies.
No problem. So price and decimal. Again, this is one I probably not, maybe not spend too much time on, just because.
Yeah, I think if I can get the, if I can do, if I know A, like if I know the revenue function, then I can do the rest of it. But since I couldn't find out A, I couldn't do the rest of it. So
Sure.
um,
Find the revenue function R. So demand X for a certain amount of product is given by the price demanded for. So I think you're going to go like this right here. So first things first, what, 161? So the demand revenue is numbers that you sold times the price that you sold it at, right? That's the revenue.
okay.
And that is, I'm not sure if it's covered in the textbook or if they just assume you should know that already from algebra. But if you essentially, if you sold 5 items, they were worth $50 each, you got yourself $250. And it's a quadratic
Okay.
formula because if you flip that around, let's say you sold 50 items, right, at $5 each, you still get the same exact revenue, right? That's the whole point of revenue. It's number of items sold times price. And so in this case, we do have a price formula. We have a P relationship and an X relationship. So price to value. So it's 10 minus. So we're going to substitute this little P value.
Okay. So it's X. Okay. All right. That makes sense.
And then there it is. And this is taking account demand. That's what it's trying to do. And that's always the case. It's always
Okay.
going to be, it's always an upside down parabola, because when you eventually, when you get it, you're always looking at something like this. If you charge $0, you're going to get zero. And a certain amount of point that you're going to charge the price so high that no one wants it anyways. And so then your peak is going to be, where's that little middle sweet spot?
Okay. All right. That's because I was looking at, there's an example 5 in the video where you guys talked about marginal cost. And I just wrote down R of X equals revenue, but I didn't know the XP thing, so that's helpful. Thank you.
Sure, absolutely. And you guys talk to me here. I know I just looked at your email just before we got started here. So you guys asked me the questions. We're good? Anything from 3.4, anything else from 3.4? Nope. Okay, 3.5. Let's go with that one. And if not, we're going to keep on going. So anything from 3.5.
3.5, I had 2 questions. One, on 191, I got a different answer than what was in the answer key, and I don't know why, because I mean, I'm doing the same thing for like example 193, but I got the right answer for 193. So
Sure. Yeah, let's take a look at it. X sine X minus cosine X. Is that
yeah,
what it is?
yeah.
And we're trying to find the second derivative, right?
Yes.
Okay, let's go with it here. So you see I see a y that's going to be changed into dy dx. This looks like a product rule to me. So that means it's going to be derivative of the first one times the second plus derivative of the second. So sine goes to cosine times the first, then minus cosine at the end. Are we good there with that one?
Yeah.
Okay, so I got sine x plus x cosine x minus cosine x. Okay, then I think back to my trig days and I think to myself, is there any rule ever that applies here anywhere? No, it doesn't. Okay. Okay, so that's the first derivative. So I'm gonna now go to my second derivative. So
Does the second part, the cosine, so like it's x sine x minus cosine x, does that minus cosine x turn into a plus sine x?
where? Oh, yes,
The
yes, sorry. Thank you so much. I totally forgot to take the derivative. Is that better?
yeah.
Yeah, derivative of cosine is negative sine, so it's a negative of a negative sine, and you get yourself positive sine x squared. Perfect. And this one, the same thing applies here. Derivative of the first times the second. Oh, okay, hold on. So at that point here, because we have 2 sine, normally what we're going to do is we're probably going to do something looks like this, right? You simplify as much as you can out of it. Sorry, 1 second. Let me get rid of stuff. That's still the first derivative, right?
Mm-hmm.
So now that that's simplified, now let's go on to the second derivative. So that's going to be 2 cosine x. So I'm going to cosine derivative first times the second plus derivative of the second times the first. And looks like a negative x sine x to me. That's what it looks like. Now I have 3 cosine x minus x sine x. Talk to me.
Okay, that's what's in the answer key. I think I forgot to do the product rule one of the times, and that's what messed me up.
Okay.
And then for 197, I was just confused on what I'm supposed to do, I guess, what they're asking.
One of is the next, in which that guy has a tangent line horizontal. We're going to be doing a lot more of these here. So yes, that'll be a good one to do. 197?
Yeah.
It is. Enrique, just make sure it's -3.
Yeah, -3 sine x cosine x.
Okay, so this whole concept of the horizontal tangent line. Very important stuff. We'll take a look at it a little bit more here, but it's this whole concept. Let's do it in terms of revenue here, since we did talk about. I have a revenue curve that goes like this. I'm renting apartments out, and I noticed that here's my bell-shaped curve. I have 100 units of apartments. And so now I know that rent in that particular area. And I know if I'm going to charge $4,000, no one's going to buy this. Okay, but if I charge $100,500, $2,000, $2,500, I'm trying to figure out, because I'm trying to maximize my rental cost, right, or my rental revenue. And so that's what this is. So if I can get this whole survey of how much rent is going for at a certain stage, and I have 100 units, I want to get that little peak. And notice what happens with that slope. That slope is positive, maybe a +5, +4, +3, +2, +1. And right at that little curve there, there's your tangent line. It's your slope line, but it just peaked out. And that's exactly what I want. I want the maximum, or sometimes if it's an inverted parabola, and this is where we talk about cost, I want this guy, and I've just minimized my costs. Are we good there?
Yeah. So it's kind of like finding the tangent line, except the slope is 0.
Correct. So let's go for it.
Okay.
So I'm going to treat this piece right here as 1 unit. That's my first function, and that'll be my second function. I'll just tag that -3 next to sine. So derivative of the first, sine going into cosine, times the second, plus derivative of my second, which is derivative of cosine going to sine, times my first. All right, and simplifying this out, just to simplify it here, I got myself -3 cosine squared x. Let's see, plus, I think, is that right? No, minus. -3. I think it's sine x squared. You guys talk to me here. Are we good there?
Is it plus sine squared x because you have a negative sign times a -3 sign? Or,
Do that.
okay.
Negative times a negative, yes.
Is it plus?
Oh, because you have
Yeah.
the derivative, yeah, because derivative of cosine x is negative sine x, and then the front term is negative, so, yeah.
Alright.
Okay, and then I see this little -3 over here in front. So I like to write positive values in front, or I like to write sine values in front. So I'm going to move this around a little bit. Good there. This is just a little bit of algebra. And if I'm trying to solve this, first of all, I could stop here. So that's about as simple as I get right there, right? Ooh, and now we're going to get into trigonometry. Here it is. This is why we learned chapter 5 of trigonometry. This is it right here. We're trying to find out when the horizontal line, or when we have a horizontal tangent line. So that means my slope is 0. So I'm trying to find that right there.
Okay.
Now think back in your mind. Is there any which way we can simplify that out? So it would have been.
Is there a reason why you changed it back to negative? Oh wait, never mind. I see what it is now.
Okay.
Never mind.
So
Just
if it was
switched
sine, if it's sine squared x plus cosine squared x, that would have been awesome. That would have been 1, and we would have been done. This one is not. So first of all, I need to change it so that I have the same trig function on both sides, and that's easily changed. What I can do is I could use Pythagorean theorem in a sense to solve for sine x. So we're good. So talk
Yeah.
to me there. Does that make sense?
Yeah.
Okay, so 0 is equal to sine squared x minus 3 multiplying into here, and a -3 multiplying into there. Okay, good there so far.
Yeah.
Okay, so I can see a 3x squared, so that's going to be 6x squared. I need some more room here. So how about 0 is equal to 6 sine squared x minus 3?
Yeah.
Okay, totally getting closer, because now we got everything in terms of one trig function. So now let's move everything over to the other side. That's 3 Divide that, and I got myself a 1/2. Let's see, I'm taking square root of both sides. And since I'm the one taking the square root, I got that right there, plus or minus. Square root of 1/2 is equal to sine of x. And I got myself, let's see, I'm going to switch it around. Is that okay? I'm going to switch to this guy. And then, in fact, I'm going to take the square root of 1/√2 plus or minus 1/√2. I solved the equation. That's cool. Okay, now what am I looking for? So find all the x values in the graph of that guy where the tangent is horizontal.
Okay, and then this is back to the unit circle.
Uh-huh.
So is that,
Now, let me show you just where this is happening though. So if you do -3 sine x multiplied by cosine x, it's a little bit more complicated than we had in trig class, remember, because the sine x goes like this.
mhm.
If I did a -3 sine x, it would have been going like this. There's my -3 sine x curve. Then I'm looking for a cosine curve, and I'm going to multiply those guys together. So if you kind of think to yourself, that's kind of what you have. You're multiplying these guys together.
Okay.
And let me just check something out just real quickly here. Let's see. Okay, so notice it's right there. That's where we're getting that. Yeah, I just want to make sure it makes sense here. That would be pi/2. That won't be pi. Can I just do one thing here real quickly here? Enrique, what's the answer in back of the book? Just make sure.
Let
Pi/4?
me see. Let me open up the answer key. What is this? That's 3.5.
197.
They put 2 and wait.
They put 2x is equal to 2n plus 1 times pi over 2
I have, well, mine says over 4, but yeah, that's,
over 4.
yeah, I'm like
I do
double
not have
checking to
over
see.
4, but 2n plus 1 times pi. You forgot the times pi. And 2n plus 1 is in parentheses. Sorry.
Yeah. Yeah, mine is over 4 for some reason. I don't know why yours is over 2. Maybe it's because
I
you're
don't know.
not on the website or something. I don't know.
Yeah, we found out there was a question
That's the answer I got, and I had to
Okay.
look this one up. I also like starred this one.
Real quick here. Is it 2x is equal to that, or is it x equal to that?
The answer key just has the like fraction and where n is an integer, but I don't know if that's right or not. I mean, I'd assume that's x equal to that because the problem is
It's x.
find
It's
x
2x is
values.
equal to 2n over 2, and then x is equal to it over 4. That was my bad.
Okay.
That was a mistake. I forgot to make it a 4 after I made it just normal x. So it's x over 4, 2x over 2.
Sorry, Christopher. Say that one more time just to make sure. X is equal to?
X is equal to 2n plus 1 times pi over 4.
Okay. Okay, so let's go for it here. So according to this little piece right here, This is the same thing as root 2 over 2. We're good? So we're going back to unit circle again. And the question is, when is sine root 2 over 2 plus or minus? And notice it's going to be at pi over 4. It's going to be at 3 pi over 4, 5 pi over 4. And talk to me. Tell me if this makes sense, or is it like too long ago, Mr. Henjiev?
Yeah, I was trying to remember
It's-
like which of the angles it was, but yeah, that makes sense.
Yeah.
So with the root 2 in there, you know it's a 45-degree angle. If you had a root 3 over 2, you know it has to be either a 30 or a 60-degree angle. But that little root 2 kind of gives it away. And so notice what we have here. We have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So we have these odd integers. Notice all of the denominators are 4. So there's where that 4 comes from. All of them have a pi next to it. That's great. Now we just need to account for the fact that this guy has a 1 pi. That has a 3 pi. Then we have a 5 pi, then a 7 pi, and then you know where this is going, 9 pi, and then so on and so forth. So what we want to do is we want to start off with a n value that makes odd numbers for us. And so you put an n value down, you got to multiply it by 2 so it can actually skip to the next one, right? Even or odd, even or odd. And then you add 1 to make it an odd number. Because if it was just 2n, that'd make it all the even numbers. We good? So with n being equal to, let's say start off with 0. Is it when n is equal to 0, we have ourselves the 1/4 pi. When n is equal to 1, we have ourselves 1 times 2 is 2, plus 1 more is 3. Then there's our 3/4 pi, 3/4 pi, and so on and so forth. Okay.
Okay. Yeah, that makes sense. Like I get why the answer key is like that now. So, but I don't think I would have done that on my own. Unless I had remembered like, or I had
Yeah.
realized like, oh, it's for all the
I-
X values. I guess all X values is like the key, that it should be something that you can plug stuff in and find. So,
I don't know how I would have done that by myself. I had to look that up
Mm-hmm.
in book and on like the internet.
Gotcha. Will not be on the test. How about that? Not this.
okay. If it was on the test, it would just be like, we would get to sine x equals plus or minus root 1 over, or 1 over root 2, and that would be it. Or is it going to
or
be
give-
like the other tangent line problems where you give us like a, where we're not necessarily finding like a certain slope, we're more finding the derivative and then plugging stuff in and plugging it to that equation.
For this one, if you're trying to find a horizontal tangent line, so you are going to have to set it equal to 0 and solve
Okay,
that, and then there is one like that, right? So find the tangent line at a specific point. So it's not
okay,
when is it horizontal. It's more of when find the tangent line at x equals 1.
okay,
So at that point, yeah, you are just going to plug in the value then.
okay.
Once you have the derivative, plug it in. Okay.
All right, well, that makes sense. Thank you for clarifying that for 197.
Absolutely. That's what we're here for. All right. Any more on 3.5 as we're making our way through this? Jumping 3.6? Go for it, guys. Anything 3.6?
I didn't have any questions on 3.6.
Okay. All right. Any 3.7? Let's go with that.
The 3.7, I was confused on the homework problems, because like I understood what was going on in the video, like that taking the derivative of the inverse is going to be the same thing as that formula you showed us on the video.
Mm-hmm.
But then for the homework problems, I think I had trouble finding the inverse for some reason.
Mm-hmm.
I think it was kind of like I did it and then I got stuck on a problem and then I just moved on and didn't want to do it that day. So,
Uh-huh.
but I
Sure.
figured I would ask. Also, so my first question was on 261, which is, I think just reviewing how, for me, how to find the graph of the inverse from the original graph
Mhm.
would be useful.
Sure, absolutely. Let's do that. Again, this is for you guys here. So sketch the graph, the inverse function, and then use part B to estimate the derivative at 1. Okay. So 161, you can actually do it on here. In order to find the derivative, all we got to do is, oh, let's see. I thought my pen is working here. Oh, how funny. It's not. Okay. So I'm going to do this just real quickly here. We have that snipping tool there. Love it. Okay. Yay. All right. Okay, so how about this? To find the inverse function, all we do is we switch our x's and y's. So a -2, 0 would be switched to a 0, -2 down here.
Okay.
And then a -1, +1 switches to a +1, -1. Let's see when the next one. Oh, it's at 2, 2. And when you switch 2, 2, it falls in the same exact spot. So it looks like that's where our graphs are.
Okay, I think all right, so that helps because what I had done is I put it at like a 0, 2 instead of 0, -2. And that's why,
Mhm.
so I think that confused me, but that makes sense. Okay.
And then we draw it. And then it says to what, estimate at x equals 1. I'm not sure how you want to do that. When we do talk about estimating, what we normally do is we talk about either a line like this, right? When you go through these points, it's going to kind of be like that, right? So you talk about getting the slope between the 2 points, and we're thinking, okay, well, it's going to be something like that, close to that. Or notice it's a little bit less steep than that. So in this case, it would be 1, 2, 3, 4 over 2. So the slope is 4 over 2 from this dot here to this dot here. So if the slope is 2, my guess is maybe it's about 1.5 because it's a little tiny bit less than that steepness. And I'm not going to go into guessing at it when we can actually calculate it using more precise methods. Okay, we're good there?
Okay.
So yeah, but as long
Yeah,
as
that makes sense.
Yeah, part A is important for you to just understand. It's this switching of the x's and the y's.
Okay, yeah, I get that. So then my next question would be on 269, which is where I think I spent a lot of time stuck and then left off there.
Okay,
Um,
I think I like this snipping tool now.
It's very handy.
Okay.
Yeah, you can also wait. What command is that?
It's my little snipping tool.
You can also just take a screenshot of a part of your screen by Windows Shift S. I thought that was pretty cool.
S. That's cool. I'm using a detachable keyboard. That's my only problem. I hate this board because it doesn't have the Windows button on it. It's supposed to be this universal thing that does PC, Apple, and cell phones. And so, but
cell phones.
it's
Interesting.
Shift. It's what? It's Shift.
Shift Windows S.
That's perfect. Okay, cool. Thank you. All right, let's go this way. I'm going to go back up here real quick here to find my little formula, if you guys know it.
So what I did was, because they don't give you the inverse, and I know that to find the inverse, you switch the x's and the y's.
Uh-huh.
so I did that, but then I got confused. Like I got to a point where I wasn't sure how to continue separating the y's. And I looked online for calculators. I tried that calculator that you recommended. I don't think it was for finding the inverse. It was like oh, I don't remember what it was called. Symbolab.
Yeah,
And it just said Symbolab it can't do this at this time. And I was like, oh great.
it's not yours.
And there was a Wolfram Alpha Beta thing down, so I tried that, and then it gave me this monstrous fraction with like these huge radicals, and I was like, okay, that can't be right. I'm like overthinking this somehow. I'm doing something wrong. So
Mm-hmm.
yeah, and then I moved on.
Oh yeah, no, good, good. Moving on here.
So
Let me see if we can get it here because I'm thinking. So
I'm
here's
sure it's
right?
just me.
Oh no, I don't think so. It could be something different.
For 269 and
Sure, what do you say?
let's see.
What's the answer to it, guys? Let's
It's like
look backwards
I
here.
know how to find, like once I get the inverse, I have the inverse. I get that like I could just take the derivative of it. Um,
You
and
just have to find the inverse.
that's the same thing as, well, from the lecture, like
Mhm.
I get the lecture made sense to me, but then for some reason on this one, finding the inverse was like this really difficult thing.
Yeah, yeah. No, I'm looking at it myself right now, thinking it's a little unusual there. Let's see. Because normally you find inverses of trig functions and things like that. What is the answer?
It's 1/5 because they want you to take, it's like the derivative of the inverse and then plug in the a value they give you into that.
Mhm.
So the answer is 1/5, which isn't terribly helpful. But
Okay. Let me actually think about this just a little bit here.
so I switch the x's and y's, so you get y cubed plus 2y plus 3. Then you move the 3 over, so you have x minus 3 equals y cubed plus 2y. And then I was just looking at that thinking, well, I can't take a cube root because then I'll have
Yeah, sure.
just
Yeah.
2y under. So
And polynomial functions don't lend themselves to finding inverses. That's my little issue here. 1 second. Let me go a little further down real quick here. For each of the following functions, find this guy. Okay, we have that. Let me think about this here just for a second. I'm going to go back up here. Nope, inverse functions here. Let me see the relationship here.
I kind of want to just look up that Wolfram Alpha thing again, just to like take a screenshot of it and show it, because it was, I saw that and I was like, no, that can't, there's something wrong. If what I'm thinking.
Something's going on.
I think they're just trying to test you this right here, Enrique. It's this whole concept. Notice the slope here. Do you see my little cursor or no?
That makes it look so complicated.
Yeah, but here's the relationship between that and that. The relationship is the slope of the inverse line, P over Q, is just going to be the reciprocal. Now this one becomes Q over P. So let's try. I'm going to try this real quick here. I think that's what they're trying to get at. And so if I take this guy to take the derivative directly, since I'm not going to find the inverse function, it's going to be 3x squared plus 2x, or just 2. We good there?
Yeah. Yeah.
At x equals 0. Nope. I'm getting, that would have been 2, right? Or am I missing something? Am I missing something here?
It says 1/5.
Well, that's after you plug in the
Oh, he's just looking for that.
this is what Wolfram Alpha says is the inverse of that. Their beta inverse calculator, mind you.
Mm-hmm.
Eh.
I looked at that, I was like, all right, I'm done with this problem. Okay, so the trick is that you have to recognize that the slope of the derivative of the inverse of A is the opposite of the inverse of A.
Reciprocal.
It's a reciprocal, yeah.
Mm-hmm. So here's our function right here. It's going up. You have a slope value, P over Q. If you switch the x's and y's, right? If you're just switching x's and y's, that means the slope is also going to switch.
Uh-huh.
And so that means your P and your Q are going to switch to a Q over P, or vice versa. So I think what they did is that I think they messed up, guys. I think what is happening here, and I'll check it out some more. You take this, it's a 2. And what we do is we just take the reciprocal of that. So that means the derivative of the inverse. I'm going to check it out after we finish up here. But
Okay.
I almost assume that that is true right here. It should have been 1/2. So maybe it says 5 is the answer. Is that right?
One fifth. Yeah, so 1/5.
Okay, I'm fairly confident that it should have been 1/2.
Okay.
Maybe someone
Interesting.
accidentally added the 3 and the 2, made a 5, and then made 1/5. I'm gonna go with 1 for now. And if anything,
1, 2. All right.
So on the test, will we have to know that? Like, will we have to use that, or will it be like you'll give us a function like x squared, say, and we find the inverse of that, and then do the inverse function theorem from there?
I'm not gonna do inverse function theorem,
Oh, okay.
but you guys will do graph or derivatives of sine inverse, and cosine inverse.
Okay, so it'll be like trig functions. It won't be like an equation like this.
Correct.
Wouldn't it be
Okay.
f of wouldn't the
Go ahead, Chris.
wouldn't the f inverse of 0 be equal to -1? Would that no?
Okay,
Never mind.
Yeah, you're plugging in the value when you're trying to make it occur at 0.
A is 0. All right.
I want to say it's 1/2.
All right.
Okay.
At 1, if A was equal to 1, then it would be 1/5, and maybe that's the issue too.
Right, they
Maybe.
plugged in a 1 instead.
Because I'm thinking, let's see. Yeah, 2 after that, and there's 1 after that. But yeah, I'm gonna go with the 1/2 on that answer.
All right.
Okay.
Cool. All right. Anything else from this section? Thank you for asking that question. I'm gonna look it up. There was one more that had a wrong answer on it that Sadie picked up, and it was covered during lecture, one of the lectures that we were doing homework questions on.
Yeah, it was like the thing they showed of like the calculator graph was wrong.
Yeah, yeah. So
Yeah.
151 or something like that, 139, something like that.
Yeah.
So there's some mistakes here.
I mean, I didn't have to draw it, so I put it into my calculator. I looked at it and it's like, huh, interesting. And then I moved on to the next problem. So,
Anything else from 3.5?
I don't have any other questions from 3.7. So,
Oh, 3.7. Sorry. Thank you. 3.8.
I don't think I have anything from 3.8.
Perfect, guys.
It was just the longest questions I've ever done. It's a lot of math.
Yeah, especially when it's implicit differentiation and then you go about it. Uh-huh.
It's just a whole bunch of sine of x, y, sine of x, y, sine of x, y, sine of x, y, and then you have to condense it all.
I'm going to torture you. I'm going to torture you on the test that way.
oh boy.
The second derivative is implicit differentiation.
What
I
went
do I do?
did have one question, which was, and I think this is related to one of the general questions, which I put at the general concepts I put at the end. But I'm sometimes I'll get these problems like where, and this is like just paraphrasing, where you have like f of g of x. So like something you use the chain rule for, but then that's being multiplied by another function, and then that whole thing is over another function. So it's like where there are a bunch of rules, like yeah, f of g of x times h of x over j of x, is an example I put in my email.
Mm-hmm.
And I'm just confused sometimes of like how I apply the rules, like how do I apply the chain rule in a circumstance like this? Because do I do the chain rule and then, or do I do the product rule and then do I do the division rule? Or
Oh,
I
sure.
guess kind of like an order of operations almost. Because I got to 305, and that was like at the end of the day. And so I was just a little, I don't know, that question came up for me. So
Okay.
that's something that has happened multiple times where like there'll be multiple rules happening. And I'm confused on,
Mm-hmm. No, yeah, totally understand. And this one is this one has all the rules all at once.
yeah, that was an example I put.
Sure. Let's try it because I think it'd be a good one to try. We good? It's going to
Okay.
get a little more complicated, but I think we can go for it and well too. So if I'm going to take the derivative of this guy, and usually it's actually another function right here. So this function is defined to be, and I'm going to call it, I don't know, m sub k. We good?
Yeah.
So m prime of x will equal, and let's do it. Like, again, this is complicated. If it gets too complicated, tell me, guys, okay? So what I see here is overarching, I see a quotient rule in my hands because I see a bar line. And so I'm going to start doing the quotient rule, and then maybe there's an embedded product rule or chain rule inside there anywhere. And so if I need to slow things down, what I can do is I say, okay, chain rule says derivative first times the second minus derivative of the second times first over bottom squared. Right, product rule says derivative the first times the second plus derivative the second times the first. And chain rule is unraveling the onion. Okay, so I'm going to look to this one, and I'm going to slow things down. So I'm going to say to myself, you know, I need to take the derivative of the first function, but that's complicated. So I'm going to take the derivative of this guy. Good there. That's the product of the first. And it's just going to be times the second minus, and then it'll be the derivative of the second. That's the easy one. I could just put prime of j times the first over squared.
Okay.
And that's just a way to slow things down. You don't have to, but notice on when I did J prime of X, I didn't have to slow things down. I slowed down over here. So this one I noticed, yeah, that's going to be a product rule with a chain rule inside it. And so I'm going to go down to this right here. So now, even if I need to do it off to the side, I'll do it off to the side. So I notice I'm going to take the derivative first function, which is this right here. And that's a chain rule. So I'm going to go with the derivative of f, leave g exactly the same, multiplied by the derivative of g. So I just took the derivative of the first function times the second function plus the derivative of the second function times the first. Okay, and if you can keep all that in your head, you're doing excellent.
Okay.
So now that is now going to replace this piece right here.
Oh.
So, sorry, Christopher, too much or no?
Let me figure out how to write that down. Oh boy.
Okay, that's what's going on inside Enrique's head. Okay, so now we know what's happening.
Wake, how do you not overheat?
This is what caused my brain to overheat.
Are you water cooled?
I don't know.
What? I can't even write it down properly. I'm writing like things wrong because it's so confusing.
So, but you can't write it all down at once because it will not make sense because there's too many parts, right? So you do have to do it in stages, slowly, putting pieces down. Uh-huh.
Okay.
Uh-huh.
So basically, you can just pick a rule and do that part, and then slowly move on to any other rules. So like doing it in sections.
Uh-huh. Absolutely. As long as you just quantify d over dx is what I'm going to do next. And you isolate that. And then you could do it off to the side as well. So I did this off to the side. I could have done it underneath here, right? I could have just done it right here, right? And then plugged it back in.
So for example, like say if instead of applying the quotient rule first, I decided to, do all the derivative stuff in the top. I guess then I would get like a monstrous thing. So generally, I guess a rule of thumb would be to go for the thing that's the overarching rule that like applies to everything, like how the quotient rule applied to all that stuff. Okay. But for smaller functions, like if you have the product rule and the chain rule, for the purposes of the product rule, you're going to treat the function in a function as like one thing.
You're gonna treat the function as one thing. Yes, so right here, it's p of x multiplying h of m of x. So I'm gonna treat that function as my first function. That is my second function. If I go back over here, and if I need to, I'm gonna write this out so therefore I don't get confused. There's my product rule. That's what I'm working with. And we go from there.
So then that would be like the derivative of p of x, and then you would just put h of m of x. And then plus, and then you have to apply the chain rule because you have to take the derivative of h of m of x. Okay, that makes sense. That helps a lot.
And I'm done right there, right? Here's my derivative of using that chain rule concept right there. and then I'm multiplying by p of x at the end.
Okay.
See, Christopher keeps on looking down, and then we do it, and he looks up, and he's like, "Ah, scary." It's a big problem.
I just imagine, Christopher, if that m of x is the same m of x on the previous slide. Okay, that helps a lot. Thank you.
Good. I'm so glad. All right, let's see. 3-9. Are we at 3-9? Or do we need to do
Yeah,
it?
that I'm about 3 problems into 3-9.
Okay. Are you stuck on any one of them?
Not yet.
Okay.
I think when I was watching the lecture, and I think I know why I was confused, but I would get confused because you guys, like, I would think I would get it, and then you guys would like take the derivative of something, and then like a term would show up, and I would have no idea where it came from. And I think that's because I wasn't applying the chain rule. So like, for example, the first example problem you guys did was e to the tan of 2x.
Uh-huh. Yep.
And I think I wasn't making the connection that that is like the tan of 2x is kind of like inside of the e function.
Correct. Uh-huh. Yeah. Because
And so I think that is what I was confused on, but I was wondering if we should go, if you could give like an example problem and like we could work through it and just make sure that I understand it. Cause I was watching the video, I was like, okay, this makes sense. And then like you guys we go to an example problem and then it would get a completely different answer because there were 3 terms I missed and
Mhm.
I was confused. So
Gotcha. Okay. Example problem. And let's do one with being E being the base. Let's see. Two. Okay, that would be a nice one. So here's my y value. So find dy dx.
So in this case, the 2e to the that stays the same. Does
Uh-huh.
the 2 disappear at all, or does it stay there? I'm looking for my rule right now.
So for any constant function, it is going to stay where it's at just because it's a constant function.
Okay, so it's gonna, so the 2 is gonna stay there in front of the e. Okay.
And then we're going to take derivative of e. We're taking derivative of e, but the derivative of e is actually exactly the same thing.
Right.
So that derivative is done.
But then there's the function inside of it. So then does the chain rule, you take the derivative of that and you multiply it by the 2e.
Yep. So that'll be a 2x plus 7 looks like.
Yeah.
So that is multiplying the whole entire function, right? So at the end,
Right.
just clean it up. If we were to clean it up, we would move that multiplier out in front. And finish it off like that. There's your.
Okay. All right. So I do understand it now.
Cool.
Okay, I got that one.
Awesome.
I can do that. The other one I don't know about. Whatever that was before.
That was a monstrosity. That would be like a challenge problem, Mr.
If that shows
Hanji.
up on the
Just
test, I'm just throwing my
sadistic.
paper out the window and just resigning. I'm like, nope, I'm done with calculus. I'll learn it in college.
I make sure I don't do that to you. So
You're just
Maybe
gonna
as like
see, yeah, Christopher dropped out of calculus.
or maybe as a sadistic challenge problem. See if you can find the derivative of this and all the way through. Oh, God.
did you guys see the lecture for that? You guys already watched it though, right? For
3.9, yeah.
Yeah.
Yeah, I'm caught up on the lectures. I'm also in a similar place to Christopher. I have the 3.9 homework to do.
Mhm.
So
Hey, buddy.
yeah,
That's good.
I totally haven't no life to the math for the past like 3 to 4 to 5 days of my life and completely ignored my other classes. I don't know what you're talking about. I'm responsible with my time.
yeah.
Sorry. Um,
I'm sorry.
sorry to put that wonderful thing, but are you learning a lot? And is it enjoyable?
Yes.
Yes, it felt really good once it got past like 3.2, and then it was like doing derivatives. Like, oh, this is nice. I can get into a flow, and then
Yeah.
occasionally there'd be a problem that interrupted. But yeah, it was enjoyable because I've always enjoyed like solving like algebraic equations, and this is kind of similar in that respect. So
Yeah, you enjoyed it. I did it. I'm here.
yep.
Gotcha.
All
Okay,
right.
let's see. If you are really stuck and you can't figure it out, email me and I will maybe like do just a quick video and I'll send it
All
back.
right.
Okay?
Thank you.
Do it by videos.
All right. Yeah. Thank you so much for doing this. It was
Yeah.
really helpful.
Okay,
Hope
and
your
then
Wednesday went well.
I did ask Miss Rain and I got full permission. And I think there's more like the science classes, and as long as they're small, we'll do it this way. So starting the second semester, if you guys are not back yet, we'll just zoom in into the
Oh,
class
geez, what time?
All right.
if you want to.
Oh, geez, I have to start waking up. Oh, no.
It's like the calculus starts at 9:30, right? No, 9:40.
9:40. No, 9:35. Yeah,
9:35. Oh,
9:35.
even
Oh,
earlier.
boy.
You're gonna have to send a speaker like a high quality, extremely sensitive microphone so we can hear everybody, and then just get our ears demolished when a car drives by.
Well, at least it's in the lab, right?
What
No,
if
it's
is the
house
lab gonna work?
one.
Oh, no, it is House One. Oh, my
Yeah,
gosh.
it's
It's been
house
so
one,
long.
yeah.
Last year
All
it
right.
was in the lab.
And I got my noise canceling microphone today.
Hey.
Oh, awesome.
I'm thinking we might just spoof it up awesomely for next semester.
Sweet. Oh, geez. This is going to be like
Everybody will-
stats all over again.
Everybody will be able to hear us, but we won't be able to hear them.
Enrique, did you ever like just roll out of bed onto your desk and just like just sign into stats?
No. I usually
I
like,
took
would
stats
wake
from
up. Yeah. I
I
would
took
wake
stats
up,
from bed.
I would get
Oh, you did.
dressed, maybe eat something, go to stats, wait. Yeah, you
Oh,
were
I
very,
set my alarm
you
for
were very
7.
proud of the fact that you did it in bed.
I am, because I'm proud of that I woke up. Because that was like,
right.
you know, like 6 to 5 hours of sleep every night for like a year.
Well, you just go to bed earlier.
It's easy for you to say.
Yeah, because I did.
That is so funny.
Well,
Okay,
this
let's-
isn't even
let's,
first period. This is second period.
Exactly, I can do
Put it
this.
that way.
That was 0 period. That wasn't even
Yeah.
first period. That was just
Yeah.
when
Oh.
was that, Christopher? Was that last year?
that was last year.
Yeah. Statistics was
Statistics.
0 period. So we had statistics and then trig.
Oh, that's right. Trig was first period. I remember that. Okay, now
Yep.
Trig is 0 period for me. That's why I was like,
Aha.
well, at the same time, but no.
Oh, thank goodness I don't have a 0 period this year. Oh,
Funny. How
That
are you
was
guys?
rough.
How are you guys' other classes doing? Any classes better than others?
Well, I just have a lot of stuff right now. Like I have to finish my Les Mis essay. I have to make a film for my film elective. And edit that. What other stuff do I have to do that's hanging over my head? Oh yeah, I have
English essay?
I already said that. I have a hanging lantern poem revision, which I'm supposed to turn in, and which I was supposed to receive feedback on like 2 months ago,
Oh
but
no.
I didn't. And then I emailed Mr. McCall about it, and he said, "Yeah, I'm behind. I'll get to it." And now it's like a week, and he hasn't gotten to mine.
Wait, we
so
have those are due?
yeah, I'm pretty
Oh shoot! Oh no!
I can look at the syllabus again.
Boy.
I'm pretty sure the Hanging Lantern poem, which we don't actually have to turn into the Hanging Lantern, but it's like we're writing something for the Hanging Lantern,
Uh-huh.
and we turned it in like before that big break. Yeah,
Mhm.
before Thanksgiving break, and
Oh,
then he's
yeah.
supposed to he gives us feedback on it,
Uh-huh.
and then it was supposed to be before winter break, and then the Hanging Lantern draft is due Monday.
It's due Monday.
A
Oh,
final draft, and
no.
I'm probably just gonna email him. Maybe I'll make a few changes to my poem and say, "Hey, I didn't get any feedback, so here you go."
Oh no. Oh. Oh shoot. I just wrote that and forgot about it. What did you write yours on?
I just started writing, and it turned into like me reminiscing about being younger and not having like college and the future hanging over my head.
Mhm.
Uh-huh.
So
I wrote about fusion.
Fusion, like nuclear fusion.
Like nuclear fusion.
Okay.
Because last time I
Metaphorically?
wrote about letters and he was like, it's too meta. I don't like it. I'm like, what? Come on. So I wrote
Yeah.
about fusion this time. He has to deal with like blah 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 fusion.
Well, I think I've really supposedly when you sit down to write poetry, you're not supposed to know what you're writing about and it just flows out of you. I think I've kind of gotten to that point where I like just start writing and it turns into something which is maybe both good and bad. I don't know. This is like the first poem that hasn't been related to something that I'm passionate about.
Mhm.
So
Hmm.
I have no idea what he thought of it because I haven't
Yeah,
seen
right.
the
It'd be
feedback.
good to get feedback here.
Yeah, it would have been great to see if I've finally mastered the art of poetry, but maybe it was just too good that he couldn't he was just blown away and he couldn't leave any feedback.
Uh-huh.
Yeah. It was so good, I just wiped it from his memory.
It's like the word from Aragon. You don't
Yeah.
comprehend it.
Yeah.
Thank you, Christopher, for the smiley face.
Parting gift.
Oh
Yeah.
yeah, absolutely.
We'll be seeing that more next semester.
I did want to, if you do email me a homework question, what I want to try out is PowerPoint has a record feature in PowerPoint. I'm going to try this just for you. It will be a pilot program. We're good. So
Okay.
what I'll do is I'm going to do it in PowerPoint as a slide, recorded slide, and I'm going to put it into my Dropbox, and then I'm going to give you the link to my Dropbox. We good? And I just want to see if it works. And you
All
guys
right.
tell me if it works, because that's what I really want to know.
I'll send you a question then.
Oh, yeah, that'd be cool. Yeah, just for I was trying to play with different things here, just because if I go to YouTube, I gotta record it, then I gotta render the video,
Right. And then
then
upload it. Yeah.
upload it. And I'm thinking, man, if there's an easier way to do this, that'd be great. So just for trial purposes, Enrique, yep, just give me a question and we'll go for it.
One thing, I'll have to look at my Dropbox. It might be kind of full because I think I told you about this. Maybe I didn't. I do this. There's this classical music competition for juniors and seniors done by the Monday Club, and for the semifinals, you upload your piece via Dropbox. So I have. How much space do I have?
Oh yeah, it won't be your Dropbox. It will be mine, and I'll just send you a link to mine.
Yeah, I think unfortunately Dropbox, like I remember my teacher tried to send me a recording of a recital I did,
Uh-huh.
and it was bigger than the plan I had, and I couldn't access it because of
really?
that.
Okay.
So I actually can't see how much space I have, but I remember I was uploading my video for the competition, and it was too big. was more than 2 gigabytes, which is the normal plan, so I had to downsize it. One thing though that my piano teacher ended up using was pCloud.
So much. I'm gonna write that down.
So in that one, it's like basically Dropbox, but it's a different company, and it ends up being, they give you 10 gigabytes of free space instead of 2 gigabytes, so it's much more.
Uh-huh.
So as an
I think I'm
alternative
gonna dip out.
Yep.
to
Absolutely.
Dropbox.
All right.
Absolutely.
Thank
Chris.
you.
Thank you so much for joining us.
Bye.
Uh-huh.
I did also want to ask, you're gonna send us the test tomorrow, or have you already sent it and I just completely missed
No,
it?
I'll send it probably today or tomorrow or Friday.
Okay,
I'll try to do it today if I have a little more time to finish up. things.
okay. All right. But yeah, that's the thing about Dropbox. I probably have enough space. I mean, I can't imagine that since it's a PowerPoint video, it probably wouldn't take up like, that much space. But
Mhm.
as an alternative, pCloud does give you more free space. So
No, thank you so much for mentioning. I'm going to look it up as well and see how that works. And I always thought that if you if you access it by link to a folder, I thought you can down the option is to download it, but then it wants to download to your Dropbox,
yeah,
and then you just have to play with the settings so that you download it to your computer. But I'll try both ways. We'll try both ways to see if which one works best.
yeah, I'm not sure. Yeah, but should have mentioned that. And thank you so much again for doing this. This was very helpful for
I am
me.
so glad. Okay.
Yeah, so all right, well then I will see you I guess Thursday for the
Presentations.
yeah, unless are we starting the Zoom schedule this semester or is it next semester?
No, let's see. I got two things happening here. I got the with you guys. If you want to check the schedule, it is presentations and also the oral final. Like,
Oh, right, and that's on Monday, right? The oral final?
that's what I'm going to look up right now.
Let
Just so
me see if
you
I
know.
can find. Uh, class video. That's
Loading
haha.
slowly.
Calculus class schedule. Yeah,
So
it's on Monday.
Monday for the oral, and then
The written final is Wednesday, and then the next day's presentations. Okay.
and your written final, I'll send it out this day, but then it'll be due that Thursday.
Okay.
So then I can start grading. I'll be sitting grading everything on the 12th.
All right.
Cool. Thank you
Right.
so much.
Sounds
Thank you,
good.
Enrique, for showing
Yeah.
up.
Thank you. Yeah. This was really helpful. I'm very glad we could do this. I'm
Cool.
looking forward to being in class again.
Yes, yes, absolutely. And I'm so glad we got things worked out.
Yeah. That's great.
I'm glad that you guys as students, kind of petition and ask in order to do stuff. And that's really great. Because we are teachers, I got to say, I feel like I'm teaching 6 different classes because in every
Yeah.
class I have at-home students and then regular students. And then when I get home, it's catching up with the stuff that I did in class or I said I was going to do. And then I turn around, then I start trying to catch up the at-home students with their stuff.
Yeah.
It's been a crazy year.
Yeah. Definitely has.
Uh-huh. Okay, well, thank you so much, and
Yeah. Thank you.
email whatever question you have. Okay.
All right. I will.
I think I'll
Okay.
just post it to. I'll do the Dropbox, and then I'll also, if I get an account with pCloud, I'll do that over there too, just sort of see which one works best.
Okay. All right. Sounds good.
Okay.
Then I will see you on Monday.
All right. Sounds good.
All right. Bye.
Bye bye.